The last part of the last video for this section is on this example here. Find the points on the graph f of x. So you have a function at which the tangent line is horizontal. And so in this case, as we're talking about tangent line right here, what we're looking at, that goes back to my introductory video, what we're looking at is we're trying to find the derivative. And so if the tangent line is horizontal, then we're really, what we're really looking at is, what this is really asking is find when the derivative is 0. That's what it's really saying here. Find when the derivative is 0. And so this question is really asking that. And so recall the derivative is the slope of the tangent line. The derivative, right, the slope, that's the value, not the equation, but the value. Therefore, we wish to find all the points in the graph where the derivative of f equals 0. And so coming back to here, here's the graph for, this is the function f of x, x cubed plus 6x. Sorry for my emails there. There's the graph right there. And so we're trying to find out when you have horizontal tangent lines. And this is similar to what I had shown you in Desmos, and we went through that equation there. I could actually show you real quick. And so if you look at the graph of negative x cubed plus 6x squared, and I drag the tangent line across it, I'm trying to find out when that slope is 0, and that's when it's horizontal, and that's what that question was asking. So you can see as I drag along that equation or that graph, you see it's a negative slope, which means that it's decreasing, and then you hit 0 here and 0 here. And so that's what this kind of demonstration shows you, is what the value of the derivative is at all those points. It's the slope of that tangent line, and we can calculate that again by finding the derivative and plugging in the x value that goes with it. But I know it's going to be 0 there and 0 there. So let's go ahead and look at that example. So back to the question. Find the points on the graph for which the tangent line is horizontal. And so what we want to do is you first take the derivative. Here's your function, take the derivative. Here you find the derivative of the function, and then if we set that equal to 0, like we did here, and this is the algebra of factoring, you will see there are 2 points where the derivative is equal to 0. So once we set that equation to 0, we're really asking when is the derivative equal to 0? Or when does it have a horizontal tangent line, and we get x equals 0 and x equals 4. And so that's what it was asking there as we go through those, go through that example there. And so then to find the corresponding y values, you go ahead and plug in 0 and 4 into that, and then you find out where that happens, and you can see that's 0, 0 and 4, 32. And so we can then look at this example. When is the slope of the tangent line 6? The same thing. Take the derivative, set it equal to 6, and then you solve. Here you have a more complex quadratic formula to deal with. Quadratic equations, so use the quadratic formula, and you find out where that happens. And so that's going to be kind of a question that you're asked to look at, but we can again review some of that in class again.